Good morning, everyone. How are you today?
Good morning, Miss. We're good. And you?
Oh, thank you for asking. I'm good, and honestly, kind of nervous because this is my first day here. So let me introduce to you guys. Let me introduce my name. My name is Rezky Rahmadani, and I'm from Jambi University. Nice to meet you.
Nice to meet you, Miss.
Okay, so you guys ready to learn something new today?
Yes.
Okay, that's good. So, today our lesson is about quantum phenomena. So today we specifically will discuss about the photoelectric effect. So what is photoelectric effect? Here's one question: that how can light release electrons and produce electric current? Okay, let's find out. So, the definition of photoelectric effect is it's the emission of electrons from the surface of a metal when the metal illuminated by light. Here's the illustration. Okay, so here we have two metal plates. These plates, we call cathode, and another plate we call anode. And this cathode, there's so much electron in it. And the circuit, from the circuit, we want to produce an electric current without using a battery or electric potential. So what we're going to use? The answer is light. Okay, so light, it carries energy from the small particle that we call photon. So when the photons so here's the photons. When the photons hit the electron on the cathode, we expected that the electron will move from cathode toward to the anode. Okay? So at the moment when the electron moves, that's the moment when the electric currents are produced. Okay, here's the daily connection. So, maybe for the example, you guys, have you ever heard about solar panel? That's a solar panel. So, when the sunlight strikes the semiconductor on the solar panel material, that's the same moment when the electric currents are produced. So honestly, the mechanism is not exactly the same, but the basic idea is familiar. That the light, this light, and this light gives energy to the electrons to produce the electric current. That's it. So there's three keywords that you need to remember about the photoelectric effect: metal, light, and electrons. Okay. Now let's talk about the first keyword, which is metal. So, I'm sorry. First keyword, metal. So, each type of metal that has minimum energy. That has a minimum energy for what? For keep the electron in the plate of cathode. So, the minimum energy also can write it as W0 equals H times F0. Or it also can write it as W0 equals H times C divided by lambda 0. Whereas the W0 is for threshold energy or the work function of the metal, H for Planck's constant, F0 for threshold frequency, C is speed of light, and lambda 0 is the threshold wavelength of the metal. What's the meaning of this formula? So the work function is a fixed value for each metal. It tells us the minimum energy needed to release an electron from the metal. Any question? No? Okay, next keyword is light. So, light. As I mentioned before, that light carries energy from a small particle that we call photons. So, when the photon hits the electron, it means the photons has energy. Because there's no way for the photon hits electron without using an energy, right? It must have energy. So this energy we call photon's energy. So light have energy that calls photon energy, and the photon energy can write it as A equals h times f, or A equals h times c divided by lambda, where the lambda is wavelength of the incoming light. From this formula, we know that higher frequency means higher photon's energy, and shorter wavelength also means higher photon energy. Now let's move on to the last keyword, which is electron. Now we assume that the photoelectric effect already happens. So when the photoelectric effect already happens, it means this electron moves to the anode. When the electron moves to the anode, it moves with a certain velocity. Okay, 1, 2, 3. It's maybe 3 seconds. Right? So you guys understand what I mean? That's it. So because electrons move with a certain velocity, as a result, the electron have kinetic energy. So it's still related. It has a relationship about the photon energy that we talked about before, where the photon energy serves two purposes. So the photon energy can use as to release electron from the metal, and number two, the photon energy, if there's a remaining energy, the energy becomes the kinetic energy of the electrons, and that's why the kinetic energy must be maximum. The formula can also write as AK max equals H minus W0, or AK max equals H times F minus 0, or it also can write it as AK max equals H times C divided by lambda minus C divided by lambda 0. You guys may be wondering why there's so many formulas. Honestly, this is a similar formula. This is a similar equation. I'm just substituting one equation into another. So it's a similar formula that we talked about before. From this one, any question? Okay, now. You guys are so smart. Okay, next, from this photoelectric effect, we also discussed about the graph. And this graph shows us the relationship between energy versus frequency. So, in this y-axis, there's AK max. In this x-axis, there's a frequency. And this slope, there's h. And the y-intercept is minus W0. Again and again, formula. This is still the same formula that we talked about before, right? Okay. AK max equals H times F minus W0. As you can see, this formula is familiar. This formula, it's like formula of straight line in the mathematics. Why I say like that? Because in the y-axis, we have AK max. Y-axis, we have AK max. So, okay, you see? In the x-axis, we have frequency, this, and the slope. Right hand, we have h, or Planck's constant. And the y-intercepts, it's minus W0. Okay. We have interpretation. Y-axis, AK max, that's x-axis frequency, this, and slope, this, h, or Planck's constant, and y-intercept is minus W0. So here's one question. Where do you think the photoelectric effect occurs on this graph? From this graph, which region that the photoelectric effect happens? Here, here, Where do you think? You. Where do you think? You? How about you? You know? You? You know? Okay. Here's the shadow pane. As you can see, these are the pink shadows. Here, this region are the photoelectric effect area or heavens. Why? We know that the frequency higher than the threshold, the frequency of the male. If F smaller than F0, there's no photoelectric effect happens. But if the frequency F higher than F0, the effect occurs. The photoelectric effects are happens, of course. You guys understand? Okay. Next is about light intensity and fat simulation. So, light intensity is related to how many photons come to the metal surface. It's related how much the photons arrives. Wait a minute. For proof the theory about light intensity, we will do a small experiment using fat simulation. So this is the look of fat simulation. You guys also can search it on the internet, the photoelectric effect on fat simulation. So here's the two metals that we talked about before. This is cathode and this is anode. I'm going to set the wavelength on 425 nanometer. And the intensity of the incoming light, I'm going to set it on 50%. I forgot something, so I used the sodium metal. You guys can change it here, but this is still in bahasa. So natrium, it means sodium. Right? As you can see, when the percent of intensity is 50%, the current is 0.045 or 0.045 amps. But when the intensity light, I'm going to increase it, becomes 100%. As you can see, the currents also increase, right? So when the intensity is low, fewer electrons are emitted and the current is small. But this, when I increase the intensity, more electrons are emitted and the electric current increases too. From 0.045 amps, it becomes 0.089 amps. So it's proved. It's proven by the theory that we talked about before, right? Okay, last slide. For conclusion, there is a three conditions that you need to remember for the electric effect. For the electric effect can occur. First, the energy of the incoming light must be greater than the. What is this? You guys remember? What is this? Yeah, the work function of the metal. So the energy of the incoming light must be greater or higher, bigger than the work function of the metal. And second, the frequency of the incoming light also must be higher than the threshold frequency. And the last, wavelength. The wavelength of the incoming light must be shorter than the threshold wavelength. The final key point, frequency determines whether the photoelectric effect occurs. And the intensity affects how many electrons are emitted after the effect occurs. So that's all for today. That's our lesson today about the photoelectric effect. Hope it helps you guys. And if any question for me, you guys can ask me after this class. Thank you for your attention and have a pleasant day.